Hey, what's up, everyone? This is Akiba from Freak Labs. I'm one of the Hackaday prize judges, and I'm here with Nava Whiteford. I'll let him introduce himself.
Hi, I'm Nava. I'm an occasional writer for Hackaday, and I figured I'd sit in with Akiba and have a look at the projects.
So we're gonna go through the projects and just give kind of our opinions on them, and just like the pros and cons and what we like about them. So here we go. So first project we're looking at right now is Dolpi, which is the low-cost Raspberry Pi based polarization camera. I thought it was a really interesting project in order, especially to do polarized pictures. I think that it's in a very prototype stage, so it wasn't exactly ready for manufacturing or anything. But but I thought the concept was really interesting.
Yeah, I thought it was like, I don't know, it just seems cool to be able to
Yeah.
to be able to take polarized pictures. I don't know exactly what the practical applications are, and I didn't dig into like I mean he cites a number of applications for like bomb sensing or like UFO sensing and things like this, but I wasn't too sure about that. But it very definitely I think would be a useful piece of lab equipment, and I think that like as an open science platform, I think it has possibilities as well, and that seems kind of cool. Um, yeah, maybe artistic possibilities as well in taking like polarized pictures and stuff. I don't know.
I should also mention that Nava is developing his own open lab equipment, open science lab
Hmm.
equipment, and then his background is in actually DNA sequencing and bioinformatics.
Yeah, it's biotech mostly. So I mean, I know use polarized light in interferometry quite a bit. So I can kind of see uses that I'd have for a polarized camera. I like the fact that it can take pictures with a number of different polarizations.
Mhm.
So yeah, it seems cool. I wonder if you could make it like a microscope add-on module as well, like with a C mount
That'd be interesting.
adapter on it. That would be kind of cool. But I think actually this is kind of my favorite project. I just briefly looked through all the projects, and I think I don't know. We'll see. We'll get into more depth on some of the other ones, but I really like this one. I think.
Uh,
Um,
I also think like we're actually out in the countryside in Japan right now, and we're surrounded by a bunch of farms, and I think this actually has a lot of interesting applications for farm and agriculture too. So I think it's a great project, and especially the stated goal of demining, but also for like there's a lot of extensions to other projects as well, and plus I think it's a 130-page documentation,
oh,
which
really?
yeah.
Wow, that's awesome. Cool. I mean, yeah, I just love to see what this guy would do, like with a bit of money behind it as well. Like what he could do with this project. It would be cool. Um, yeah, but I'm a sucker for science-based projects, I guess, as well. So that's maybe just me.
Okay, so I think yeah, so that's what we thought about the Dolpi. Let's move on to the next one. So the next project that we're looking at is the Farmbot, which is the open source CNC farming machine. Um, I guess I'll start off with you, Nava. What do you think about something like this?
Um, I don't know. So if I get the basic prompt, this is like a planting machine. What exactly does it do?
So it is. Let's see, it is a rail-based I think it's a two-axis, I guess a three-axis motion control machine that you
Okay.
can yeah, so you can use it for like a lot of applications. It
Hmm.
functions the same as a CNC, and so yeah, you can use it for planting. I guess you can use it for other functions as well,
Okay.
tilling,
So
etc. So
yeah, I don't know. I mean, we both live out in the countryside now, right? You in
uh,
Japan, and I live out in the countryside in the UK. And I don't know. I see some of the pictures here are with it outdoors, and I can't kind of see this thing really surviving or being a low maintenance solution in the countryside. I guess that was my kind of feeling. Um, it's kind of cool. He's clearly put an awful lot of work into it, so that's
mm,
neat. But maybe something like hydroponics,
yeah,
it could be
I think.
suitable for, like in a controlled environment.
Mm,
I can see it being
uh,
a lot better than a practical solution outdoors, I guess.
I yeah, I could see something like this being used for like aquaponics, hydroponics, etc. but I don't think that this could be used at a as a large scale. Like like for in the video, like solving the world food problem. I don't think it's quite ready for
Yeah,
that.
no, I can't see that
So
happening.
yeah,
I could see maybe the other thing is maybe like I don't know. I'm going to keep going back to research applications, I guess.
uh-huh,
But like they've converted in Japan, they've converted fabrication facilities
uh-huh.
into like
The hydroponic.
hydroponic
Uh-huh.
farms,
Uh-huh.
right? For people, and it's for people who have allergies or something, right? So they
Yeah,
grow
like
things in a very controlled environment.
the very specialty thing. And I
Yeah,
think
and for that,
that'd
that
be
could be viable, right?
yeah, yeah.
That's the kind of those are the kind of applications I could see it being useful for, or
Mm,
research applications where you're growing. You want to see how a plant responds to certain chemicals,
mhm,
so you can do different concentrations and different mixes and supply them to different
mm,
plants.
mm.
That would be cool.
Yeah,
Um,
especially like I guess if you could script the planting so that you could have reproducible planting results,
yeah, yeah.
then you can actually use it for kind of agricultural
hmm
experimentation. I
Yeah,
think that would be kind of cool.
it takes a human element out of the equation and gives you a controlled kind of system, which would be neat.
Hmm.
But yeah, again, for the kind of thing that he's suggesting, solving world food problems, I'm afraid I think probably that's not our biggest issue.
Yeah.
But yeah.
So, but I think it's an interesting project, and
Mm.
there's a lot of really cool possibilities with it. But I mean, from a farm perspective, then I don't think that like you'd be able to get it out in like even a modest sized farm out here. So
And you also like get it. Can you imagine trying to get buy-in from farmers on this?
oh
Like
yeah,
that would
yeah,
be
jeez,
like
yeah, you don't
like
wanna
that
like
that would be hard work.
possibly in the U.S., but in Japan, then
Yeah.
the farmers are older and they have like very low technical proficiency as well as technical tolerance.
Mm.
So,
Yeah.
so India as well actually. So but okay, so let's move on to the next one. So this next one is the EyeDriveO-Matic the eye controlled electric wheelchair, and I thought it was a really cool project. In fact, this was one of my two top favorite projects. But I'll let Nava comment on it first. What do you think?
Yeah, I mean, I basically know what you've told me about it, which is a quite community-driven project. So the guy like had a problem and needed to solve it, so developed the system, which I thought was awesome. I love like when I see a project that's built around a real problem. That's kind of cool. Um, it's obviously also quite a technically challenging project and has a lot of like aspects to it, both the software, computer vision aspect, and the kind of drive and control aspect. So, yeah, it's cool. I like that.
Yeah, I like it because it was actually done by people that had a need. There was like a very well defined target audience, and the people that developed it were within that target audience also. And they were testing it out, and I think they also had a bit of fun with it too. Like they like in the video they showed that they attached like kind of a Nerf shooter to it, and you could actually like a one of the guys was a quadriplegic, but he was actually controlling the Nerf shooter with his eyes, and I thought that was like just awesome.
So he shoots his kid with it or something, does he?
Yeah.
Yeah.
It was really cute. I really liked it. And I like that kind of thing with having fun with the technology too. But the technical merits are that it's something that is it serves a very well defined problem with a well defined audience. And I think it's a great project.
And it is the other thing that's nice about it is this is actually something that's probably quite difficult to develop commercially, I think.
Yeah.
So it's something where open source software and hardware really shines, because I think to innovate in this area commercially is probably quite difficult. So it's probably a worthy applicant to the Hackaday prize in that regard. Like,
Uh, Yeah, I agree, and I think that there are a lot of technical challenges, and I think there's also not any not any corporation would be able to develop something like this because you'd have to find like people that that had these specific issues or people with ALS or uh, and there would have to be a lot of research and user-driven study. Whereas, like if you had a community, then you just have like a lot of passion within the community to develop it.
But it's interesting. I was doing an article on Forrest Mims a while back, and he was saying he developed this LED based kind of vision system for blind people. So it would use the LED as a photodiode, so it could kind of sense objects, and then it would beep so that it would know when they were near something. And he said he presented this to a bunch of companies, and none of them would touch it because of reliability issues. And I wonder if you might have similar kind of commercial problems with this, in that like there would be companies that just wouldn't want to touch it because if it detected your eye motion incorrectly and you go down a hole, then they'd be liable. Which is like perhaps another reason why it might make a good community-driven project, because you can sidestep those issues.
Yeah, I agree. I think, in my opinion, I would say that like for a project like this, I'd probably try and work on the problem first and worry about the liability second, which you can't really do as like a large company. So.
Yeah, that's the problem. Yeah. Having the developer being the user must help a lot in this case.
Yeah. Well, that's what I like the most actually, is that the developer was a user of the project.
Yeah.
So, okay. Let's move on to the next one. So I'll start off on this one. So this next project is the electrically enhanced wet scrubber. It's an air purification system, or an air particulate remover. Uses electrical enhancement, basically ionization, in order to remove particles from the air, and so the designer claims like a huge improvement in particulate removal for air, which I think is actually a really great design and invention. I didn't see any hard data on like the amount of particulate, but I might have missed it. But in any case, I thought the concept was really cool, and it's a huge problem. It potentially solves a huge problem in like indoor air quality, especially in countries that really need it, like China and India, where they have like just horrible outdoor air quality, environmental issues with outdoor air quality.
He also cites PM 2.5, which is kind of interesting because that's becoming a big thing in Japan, right? It's PM 2.5 particulates that are in the air that are coming over from China and stuff, and
I think that's more like paranoia, though. I think.
Oh yeah, it totally is paranoia, and it's a big marketing thing. Because they sell all the face masks, especially for PM 2.5 and stuff, right? Which is nuts. But anyway, it's I think it's a cool project. So it's electrostatically augmented. So I guess they charge the particles.
Yes. So he creates a voltage multiplier, similar to how you do it inside of say like Geiger counters. And so you create like, I don't remember seeing the exact voltage, but probably like around a 600 volts to 1 kV 1 kV potential difference. And then so the particulates that travel through there end up getting ionized, and then they travel towards one of the plates, and so that's where the electrical enhancement comes in.
Okay, that's cool. I just think that's a cool mechanism. So that would get my vote, like to have such a cool kind of mechanism.
Yeah. And the rest of it is like basically a cyclonic separator.
Right. Yeah.
And so like a dust separator.
Yeah. No, that's neat, and I like kind of, it's a very strong like hardware project. There's probably not a huge software component to it.
It's almost all hardware, and actually more mechanical design rather than.
So I like that, because you see a lot of kind of like on Hackaday generally you see a lot of kind of software-y type projects with a small hardware component, but this is pretty much all hardware and a lot of mechanical design, which is also kind of rare. So that must have been a fun project to do, and obviously an important kind of an interesting application.
I think like actually it's still in a very rough state, but I think with with some like proper CAD design and actually mainly just like proper CAD design, maybe discussing it with a mechanical engineer, and then I think it could actually turn into a viable product.
Yeah, sure. I mean, this is perfect for a first prototype, right?
Yeah, yeah.
I mean, this is exactly what you want. It's something you just knock together as quickly as possible and as cheaply as possible, and kind of have iterated over. And then once you've got a stable working system, you can just go to, well, start thinking about doing things in a way that are amenable to volume manufacture, I guess.
Yeah, yeah. I mean, I'd probably take this project and I'd apply to like, I guess one of the, I'm not a huge fan of hardware accelerators, but I'd probably take this project and probably apply it to one of the hardware accelerators. I think it'd probably be under consideration.
Yeah, it's definitely at the stage where you've proved out the concept, and yeah, cool.
Nice. Okay, so this is the portable environmental monitor as one of the entries, and it's a radiation radiation dosimeter, and also a air quality monitor, and it has gas monitors. So I think both of us have a bit of experience on radiation monitoring, as well as some experience on air quality monitoring. So I guess what do you think about this?
Well, yeah, I mean, so we both have a background in radiation monitoring from Safecast. So you were kind of, I guess, one of the founder members of Safecast, and I came a bit later to help Bunny with his Kickstarter Geiger counter, which was kind of a Safecast project. So we both have some idea of how painful and hard it can be to build a practical environmental sensor radiation monitoring system. And this guy has done something very similar. So we both know this guy from his Radu sensor network, and he's done some really good work, I think, in radiation monitoring. So he comes to this project with kind of a strong background in this stuff, which is kind of cool. So I have some confidence that this thing will work well and incorporate a lot of the solutions to the various problems that you kind of encounter. Yeah, so it looks cool. And I think a generalizable kind of sensor is neat, because for Safecast, you have to build everything from scratch, right?
Yeah, yeah. So I think yeah, I mean, well, I guess you can buy Geiger counters, but yeah, they don't have like mixed like Geiger counter air quality monitor type thing. And then let's see, I know there's been a lot of work with people doing portable like particulate counters, and I think those are really interesting. I think air quality is notoriously difficult to monitor. So when I was looking at it, I wasn't sure like how well calibrated you can get the particulate monitoring to be, because you actually generally you would need kind of you would need to specify like what kind of particulates you are monitoring, and also you would need some kind of a controlled air intake, controlled filtering, and then like some kind of like a optical chamber to count the particulates.
Yeah, and that can be a problem with some of these projects, is that like they try and acquire a whole load of data and hope that it comes out in the wash. Like they just filter it and like they can do visualization, but a lot of it is actually in getting a really good, well calibrated sensor, right? And in particular for Safecast, you guys found that like focusing on particular kind of pancake sensor was like the way to go, right? And
yeah. Well, actually, I mean, like you would focus on for radiation monitoring, you would need to focus on one type of sensor, but you would also need to calibrate the sensor and also have certain shields, like you'd want, for like if you wanted to measure in like say the dosage in microsieverts or something like that, then you would need to have some kind of filter in front of the sensor in order to the Geiger tube, in order to block out any kind of like beta and possibly alpha. And so it gets very complex, like all this stuff. And so like I think a lot of the difficulty in radiation monitoring is in calibration and like following the kind of generally accepted standards.
Sure. Yeah, but I think I like the idea anyway of having a more general sensing kind of acquisition system. I think that's kind of.
I mean, yeah, I think it's cool. I like the fact that you're getting you now have access to all these kinds of things and the sensors and all that stuff.
Yeah. So one of the things he targets is like PM 2.5, which is kind of a buzzword right now, I guess. Particularly in Japan, people seem to talk about PM 2.5 an awful lot as a kind of almost a marketing gimmick for face masks and things, right?
Yeah, yeah, yeah.
But it's a clear issue, and it would be nice to have the data, and I think that's something that with Safecast as well, it's always seemed like really important. Well, just give people the data,
Uh-huh.
and then they have the ability to make their own decisions. So that's cool.
So yeah, it's pretty. Yeah, I think it's interesting. I do think that like I don't think like crowdsourcing like crowdsourcing data or kind of just like throwing data out there and expecting people to convert it, like do magic on it, is exactly the way to go. And especially from Safecast, is very difficult to get that kind of volunteer help. And eventually we had to use like grant funding to pay people to actually do the visual,
Right.
to actually help us with the visualizations.
Yeah, that's true as well. Actually, it's a tough problem.
Yeah. So I mean, but I think it's a great project, and I think it's needed. It's just it's unfortunate that I have like experience with this issue and like all the.
I think that's I think this project is one that's very close to both of our kind of hearts. Like in that it's like, oh my god, that's going to be so painful. And what about this issue and this issue?
yeah.
But yeah, it seems like a nice, well designed project, I guess.
Yeah.
Yeah.
So, actually, the next project that we're going to look at is the Solar Electric Utility Vehicle, which is a project that came from a designer that is working out in Africa and in a resource-constrained environment, and he developed it out of his own need, which I thought was really cool. I have a couple things to say about it, cause I work out in resource-constrained areas like Himalayas, but I don't know.
I mean, I guess,
what do you think?
This is going to be all round a more interesting project for you than me, I guess, because it incorporates like solar power and those kind of things which you're kind of heavily into. It seems kind of cool. I always worry a little bit about the practicality of these things, but if this has come out of his own needs, then that sounds like it could be. I like projects that come out of a need, so that's cool. Yeah, I don't know. What were your concerns?
I think generally it's pretty cool. I'm not sure that you need like the solar panel attached to the back of the or to the top of the car or the vehicle.
Yeah, I mean that could as easily be like just a stationary solar panel, right? Just plug it in to charge it, I guess.
Yeah.
Or even like as a more practical way would seem to be like it charges up a set of batteries and you just manually swap out batteries or something, maybe.
Well, I think that's the way that I would probably go about it, because like unless you're traveling across like the Gobi Desert or something like that.
Yeah. But it's
I think
the other thing you can really see about it is it's like I would have thought it's only going to be useful for like short runs, right?
Yeah, I think I would. So like I think that in general, like there are other groups that are kind of doing similar things. And you'd have the solar panels, that would attach to like a MPPT charger, and that would charge batteries. And so
these are SLA.
Generally, SLA batteries, like sealed lead acid batteries. And then you would use those batteries in order to like power whatever you need to power. So they might power your vehicles. My friend is actually a big proponent of electric unicycles, which are like really cheap out of China.
Yeah.
And then so then you can power.
I'd love to see how an electric unicycle would do out in Africa.
He's using them out in India, out in the
Really?
the rural India.
Okay,
and
cool.
then the
So
unicycles
like mud
actually,
tracks and things they work on, or
well, I think they negotiate the dirt roads pretty well.
Okay.
Yeah, it'd be really interesting to see what kind of modifications he does, because he wants to do like kind of off-road unicycling. So
okay.
But yeah, it's pretty interesting. But yeah, generally, because if you have a general purpose battery, you can also use it to do important things like charge phones or provide light. And I think actually street lighting is a huge concern, is a huge safety concern in a lot of developing areas, or a lot of refugee areas too.
It's just I mean, I would hope it's built around like a standard building block like lead acid battery, which can have a bunch of applications like you can just find and reuse and stuff. Would be kind of
Yeah,
cool. Yeah.
yeah. So I think it's a really interesting project, and I like the fact that it came out of his own need, and he just
Hmm.
kind of built it out of available materials. I think that's really that's really the spirit of hacking. So like I like that.
Yeah.
I don't think it's a practical project in terms of or it would need a lot of polishing in order to turn it into like a viable.
Yeah.
Uh,
No, it's interesting. It looks like
product.
he's done like a significant amount of work on like the mechanical side as well,
Mhm.
and
Yeah.
making sure the system is like stable on dirt tracks and things like that. So
Mhm.
that sounds pretty cool. I like. I know. I'm kind of a sucker for mechanical projects as well because it's something I'm not very good at. So I always like to see it and learn more about it. So yeah, cool.
Okay, so the next project that we're going to look at is the Vinduino, the Vineyard sensor irrigation control device or network.
Hmm.
So we were checking out the video and like kind of discussing it a bit, and I think I'll let Nava start off.
I think, well, okay, so firstly, I think it's pretty cool. I like the fact that it closes the loop on the irrigation system.
Uh huh.
So you don't just have to throw a bunch of water at the plants and, figure that they'll get enough. It kind of closes that loop and you have some feedback. And it
Hmm.
always makes me feel nice as, like, an engineer and a scientist that, you have some measurement that tells you, okay, this is working.
Uh-huh.
So it's kind of more calibrated. The thing I didn't like about it is it's kind of always a bugbear for me when you see you kind of look at the PCB and it's a carrier board with like an RF module and then an RTC module and then a Wi-Fi module and then like an Arduino that ties the whole thing together. And as a computer scientist, anyway, it just pains me to see like an ESP8266, which is how far does they go? Like 200 megahertz, 100 megahertz.
I'm not sure.
They're
I believe
reasonably. They're
yeah,
like they're fast.
they're 32-bit
They're
processors.
32-bit
Yeah,
processor,
they're like
and
fairly fast. Yeah,
and then
they have
you
decent
you
time.
see them being like subservient to like an Arduino, and it's just kind of that always it kind of grinds a bit. Like I would like to see, yeah, the ESP is pretty good, but and I don't know. So it's difficult because in some ways I can see it's probably a good way to go about it.
Uh-huh.
For a prototype, plugging everything together, I
Uh-huh.
just feel it makes me feel all kind of weird.
Like I think I kind of understand your point of view, but I think it is a bit of technical snobbery because I think
Yeah,
the main
yeah.
thing is just to get something that works first,
Absolutely.
and then you
And
check
like,
it out.
particularly
I
like
think
all the modules, like it's a $2 module, and then, like the Arduino is probably a few dollars.
yeah,
And
yeah,
it's
yeah.
like
Especially the knockoff Arduino, the
Yeah,
knockoff
yeah.
Arduinos from Shenzhen are like $5 now.
yeah. So I don't know. I mean it's fine,
Uh,
but I'm a little bit weirded out because I've done some ESP8266 coding and
mhm.
it's pretty powerful. It's just a
Uh-huh.
little bit it's a little bit more difficult to work with. But,
I think the tool chain kind of sucks. At least when I was playing around with it, I haven't tried the Arduino version of it
yeah,
yet. But,
yeah. It's true, but it always feels. I don't know. It's another one of those like Arduino versus X kind of things, I guess. Um, but yeah, cool project. I like the fact that it closes the loop. That's cool.
Yeah,
Uh,
I like the fact that it's very specifically targeted. Like like one thing that I really don't like, or I think is a sign of kind of more of an amateurish engineering effort, is like when you have a design that doesn't target a very specific application. So like when you have designs that target a very specific application, then I feel like those are designs that can be like very well specified, very well kind of the problem domain is well known, and then you can actually create like a very good design. Whereas I think a lot of the like more beginner designers kind of try and create something that's like a very general purpose, like just throw like 8 million sensors on a board and see what happens.
yeah. Because it's got all of it's got all of the different sensor inputs, and it's kind of interesting that it's got Wi-Fi and like a long range RF. Right. Whereas you
yeah,
could
that's
see
interesting.
that like that's.
I
Yeah,
think
I don't know if I would like the power consumption must go up an awful lot because of that, right?
yeah. Actually, I'd probably say like the one of the problems with working with modules is like why I don't like to work with modules personally is because a lot of designs don't take into account like proper power management.
Right. Yeah.
So like and yeah, having to like the ESP8266 is a big power sucker. So actually, I don't know if I would have put that on. I would have just kept the long range RF and just like kind of turned it on and off as needed.
I'm a bit confused as to why you'd put Wi-Fi on it, to be honest. I mean, maybe you can do firmware updates for it, but if it's got long range RF, then like I can see maybe you'd have one central unit which has like Wi-Fi, and then everything uplinking to that. But I guess it's like maybe like a first or second revision. So I don't know. Shouldn't be too harsh, perhaps. But it's always interesting counting the number of like regulators on these boards as well. Like because like each module is going to have its own regulator.
Oh yeah.
Because like they don't know what the input's going to be, so they put their own regulator on there. So you can see, oh, there's a regulator on the main board. Oh, there's a regulator on that module, on that module, on that module. So it's kind of like you say, the power management is an issue.
But so FYI, like so Nava would always get on my case too, because I like using Arduinos because they're fast, and even though they're like they don't they don't have like a bunch of computing power, then I like them.
It just annoys me because like you can buy so much more compute for what you pay for an Arduino, right? Like I don't, it feels like we should be programming ARM cores more than like AVRs. I mean, I was using AVRs when I was like a student. Like when I was at school.
I agree with you, but as another aside, when there's a time crunch and something needs to be done quickly, then Nava also pulls out the Arduino. So
Arduino's for everything. That's why I'm a total hypocrite. I use it for everything. I bought like 50 Arduinos off eBay recently, just because I use so many, and I've got none left. But so I totally like. Yeah, I understand.
There's some context for all you.
I understand that they're very useful, but that's just like because I'm an ARM guy, right? Because I used Acorn computers at school,
because he's British.
Yeah, I was programming ARM when it wasn't cool. Damn it!
Back when they were called Acorn.
Yeah, so Acorn RISC machines, man. So. Yeah, so I feel like I should be programming ARMs more, and I've tried, but you're totally right because I tried the STM32 based Arduino clones, and there's no way it's easy. So I always reach for the AVR, but yeah, I just feel bad about it when I do it. I think that's the right thing.
So I think the point is So there's a bit of a rant on like the usage of just a lot of modules in a carrier board. But on the other hand, I think it's a great project, and that it was minimal effort to get results, and I think that's what really counts.
Yeah, and at the end of the day, I think like proper engineering is about solving a problem in the most expedient way possible. So you kind of you solve the problem within your specification. So and I guess that that's what he's done. So
yeah.
So you should use an ARM. that was gonna get some comments.
This next one is the Open Bionics affordable prosthetic hands. It's actually this was sorry, those are the motorcycles outside Hacker Farm.
The joys of living in the countryside.
Like I had two designs that I really liked. One was the eye tracking wheelchair, and the other one was this one, which is the prosthetic hands, the low cost prosthetic hands. And I think I really liked it because it serves kind of a very interesting market, because I think there's a lot of people that have like disabilities where they can't use their hands, or they're missing a limb or something like that. And also it also can be used for something like industrial manufacturing, or like robotic manipulation of things, which I think is kind of where things are going as well. So I thought that was interesting.
I'm a little bit more skeptical than you, I guess, on this one.
Mm-hmm.
I liked it, but I liked the eye tracking chair a lot more because because they had designed it out of a need, and it was a very pragmatic solution. It seems to me to the problem. This project, just my first impression is it seems a lot more academic. It seemed to be academically motivated. And they'd kind of looked at the existing research in the area, and they've built on the existing kind of research. And it's like, there's parametric models for the hand, and I can because I can see it from my point of view, like from when I was doing a PhD and what I would have been looking for, and it's like, parametric model for hand, okay, paper in that, and okay, proof of concept example, okay, there's paper in that. I didn't see anyone in the video who actually needed this, any actual kind of testing with a user who would actually have wanted to use this. So it feels a bit like, I don't know, it's obviously an important problem, but it felt like, I don't know if they really were engaging with users and kind of iterating the design with a user. That was my worry. I may be projecting some of my own issues with academia onto that, but
he hasn't had the best experience when working with. Actually, both of us haven't had really great experiences working with academia. So.
Yeah, and I'm a refugee from academia, I guess, in a way, because I did my PhD and postdoc, and then kind of went into industry, and I've seen the issues that industry has had with working with academic type projects. So I think I'm projecting a bit. but yeah, an important issue, an important project, and obviously it looks kind of cool as well, which is neat.
I think there's a lot of interesting applications even outside of prosthetics, but I think prosthetics, especially low cost prosthetics, is definitely a very important need, and especially in a lot of war-torn countries or countries that also punish you by chopping off your hand or something like that. So.
Right. Yeah. What did you think about the fact that the parts are 3D printed? Because I kind of have I wonder about how much 3D printing gets used in situations where it may not be entirely appropriate, and they might have been better going with getting some parts machined out of aluminium or other options.
I think most likely they probably 3D printed the parts because they had a 3D printer.
Right.
And so, I think...
Do you think... I mean, I don't know. I kind of feel like 3D printers sometimes get used a bit like that. They get used because you've got them, rather than the ideal solution. Or
well, at this stage, it's a prototype. And then, I think if I was going to do it and then I wanted to, have, an extra cool factor, then I probably would have had it machined out of aluminum.
Right.
And a lot of people aren't aware that machining aluminum is extremely cheap. So you can just go to almost contract any prototype shop in Shenzhen, and then they'll just machine stuff for a disgustingly cheap amount of money.
Because I guess any kind of I would imagine this is going to fail quite quickly in its current form. I can't see someone using this day to day and it lasting for more than a few weeks. I don't know, because of the plastics, but.
I don't think this is a production model. I think it's more of a prototype. And so if I was going to take this into production, then I'd probably start experimenting more with
I'm being too harsh, I guess.
Polycarbonate or something like that. Yeah. I mean I think because I don't think it because you can 3D print the parts, then I don't think it'd be a problem to injection mold the parts either. So I don't see that,
but sometimes
being the problem.
I don't know. Sometimes you could, because you can do in 3D printing things you can't do with injection molding. So I guess you have to be careful about that too.
Well, you can do undercuts, but generally, I think you could pretty much do everything. Anything you can do in 3D printing, you can do generally in injection molding. Except for the whistle thing where you have something just kind of embedded inside. But otherwise, then it's just it depends on if it's a 2-part piece or a 1-part piece. So.
Okay.
But I think, yeah, actually, I think your comments are pretty valid. The only thing is like the part about academia is
Yeah,
it's a
that's
bit
mine.
like,
That's
I
clearly
think
I'm projecting.
perhaps some therapy is needed.
Yeah, I don't know. I'm slowly. I'm getting through it.
So I think that covers all of the projects that at
Oh,
least
really?
I was given to
Oh,
review.
cool.
Yeah, and then
Okay.
and so I think it was great. Like there were so many projects, it was really hard to score everything. I couldn't really make much of a like. Everything was really close, and it's hard to make a decision. Like I had to ease a lot of my criteria in many cases just because there's like, or even I started giving like decimal points because so it's
Yeah, it's tough actually, and they're so diverse as well.
mhm.
So it must be really difficult to compare the different kind of projects. So yeah, unenviable. I'm glad I don't have to do it.
Yeah. The early rounds were easier to like separate the wheat from the chaff. But yeah, so good luck everybody, and hopefully someone gets like the huge payout or the trip to space. And just remember that have a bunch of like broke ass engineers out in the countryside, like living the farm life. Peace.
Cool.
I'm not gonna rant. So hold on, I'm gonna.
I feel like actually, it's probably easier for me to rant about things because like I have no influence over
Motherfucker. So luckily, since I'm gonna edit, I can edit out. I can cuss all I want. And then, yeah. I like those.
SND, you use that?
Yeah. Let me tell you, it's all about skills, my friend. It's all about skills.
That's right, it is.
Cool. Let's see. I have to stop like staring at like the screen rather than. Like
Yeah, I don't know. I'm mostly talking to you.
Okay.
So I feel like I'm here as the sidekick. So.
Okay, so this next one is let me restart that again because I just burped.
That all adds to